You take any crazy idea. Well, I don't know, it's hard to make up a very crazy one. Say witches or something like that. You tell about what people used to believe about witches. Of course, nobody believes in witches now. And you say, how could they believe in witches? Then you turn around and say, let's see what witches we believe in now. What ceremonies do we do every morning? We brush our teeth. What is the evidence that brushing the teeth does us any good in preventing cavities? So you start wondering, are we all imagining things? As the Earth turns in its orbit, there's an edge between light and dark. And along that edge, all the people are doing the same ritual for no good reason. Just like in the Middle Ages, they had other rituals. And you try to picture this perpetual line of toothbrushes going around the Earth. It's to take the world from another point of view. Now, it may well be that brushing teeth is a very good thing because it gets rid of cavities. And you're going to ask, you can find out whether it does or it doesn't by trying to find out. Now, you're going to ask your dentist. He says, of course. And you say, how evidence? I have not found the evidence from dentists because they just learned it in school. Now, I'm not trying to argue that it's good or bad to brush teeth. What I'm trying to argue for is to think about things from a new point of view. You see, I have had in my life a number of pleasant experiences. One of the earliest when I was a kid. I invented a problem for myself, the sum of the powers of the integers. And in trying to get the formula for it, I developed a certain set of numbers for which I couldn't get the formula. Later, I discovered that those were known as the Bernoulli numbers and were discovered in 1739. So I was up to 1739 when I was about 14. Then a little later, I discovered something. I found out I had just invented a thing called what we now call operational calculus, and that was invented in 1890-something. I was gradually inventing things that came later and later. But the moment when I began to realize that I was now working on something new was when I read about quantum electrodynamics. I read a book and learned about it. For example, I read Dirac's book. He had these problems that nobody knew how to solve. I couldn't understand the book very well because I really wasn't up to it. But there in the last paragraph at the end of the book it said, some new ideas are needed. So there I was. Some new ideas were needed. Okay, so I started to think of new ideas. My father had already taught me about the names of birds. Once we walked and he says, that's a brown-throated thrush. He says, do you know what the name of that bird is? It's a brown-throated thrush. In German, it's called something else. In Chinese, something else. In Japanese, something else, and so on. And when you know all the names in every language of that bird, you know nothing about the bird. Then we would go on and talk about the pecking in the feathers and so on. So I had learned already that names don't constitute knowledge. Knowing the name of something caused me a certain trouble because I refused to learn the name of anything. When someone comes in and says, you got any explanation for the Fitch-Cronin experiment? I say, what? What's that? Then he explains the phenomenon. Oh yes, now I know, but I never know the names of things. The basic principle of knowing about something, rather than just knowing its name, that's something that stuck with me. You have to learn certain disciplines in the field of science to know when you know something and when you don't know, and what it is you know and what it is you don't know. You have to be very careful not to confuse yourself. We had little games. He would say at the dinner table, suppose we were Martians. We came down to Earth and looked at things from the outside. There's a way of looking at something as if you never saw it before, for the first time, and asking questions about it as if you were different. For instance, suppose you were a Martian who never slept. You came down to Earth and saw people who had this funny habit that every day for a certain amount of time, they lie down and become unconscious. The natural question would be, how does it feel to become unconscious? Do ideas run along and suddenly stop? Do they run more slowly? So I tried to answer the question, what happens when you become unconscious? When we get stuck on a problem, it's because all the known methods don't work. If any of those methods worked, we'd already have the answer. So when we get stuck, we're at a place where history will not repeat itself, and that's what makes it exciting. Whatever the new method or trick is going to be, it will be different from anything we've seen before. The real test in physics is experiment. History is fundamentally irrelevant. It has to do with curiosity, people wondering what makes something do something. Then discovering that the answers are related to each other. The things that make the wind make the waves. The motion of water like the motion of air, like the motion of sand. What we're looking for is how everything works, what makes everything work. And it's much more exciting to discover that we're on a ball, half of it upside down, spinning around in space, held by a mysterious force, going around a big ball of gas that's burning. That's much more exciting than stories about the world sitting on the back of a turtle. The truth is more remarkable. And the pleasure in physics is that as it's revealed, the truth is so remarkable and amazing. The world is strange. The whole universe is very strange. But when you look at the details, you find that the rules of the game are very simple. When the situation is simple, you can figure out exactly what's going to happen. Yet in the real world, there are so many pieces, you can't figure out everything. It's hard to believe that the behavior of people, talking, nodding, all this, is the result of lots and lots of atoms obeying simple rules. There's such a distance between the fundamental rules and the final phenomena that it's almost unbelievable. But it really is just a lot of it. We are getting close to understanding the patterns of particles. One picture describes particles as being made out of things called quarks. A quark comes in 3 varieties. Particles like protons and neutrons can be understood as combinations of 3 quarks. Another class, called mesons, are made of a quark and an antiquark. This explains many patterns we see experimentally. But there are paradoxes. We don't know exactly the laws that hold them together. Some experiments suggest that inside a proton there may be infinitely many particles. Nature looks simpler than it has any right to be, and we must understand that simplicity. Nature is no doubt simpler than all our thoughts about it now. It has to do with curiosity again. If you try to figure out the conditions under which you get a great idea, I've tried many times to figure that out. Once I worked on the theory of helium for 2 years. Suddenly everything became clear. You can remember the color of the paper you were writing on, the room, everything. Then you try to recreate that condition. You walk on the beach and say, it can't be so complicated, but nothing happens. The moment of insight is very big, but it doesn't last very long. And the hope of that moment keeps you going through the difficult times. And afterward you wonder why you were so stupid that you didn't see it earlier. But that's true of the history of science, too. We're still very bad at understanding nature. We're doing the best we can.